Okay, a new unit in geometry. This is unit 9. It's called 2D and 3D measurements and modeling. In today's lesson, we're going to focus on the area of parallelograms, triangles, trapezoids, and rhombi. Okay, so we're just going to hit the basics here. Recall that a parallelogram is a quadrilateral with both pairs of opposite sides parallel. Any side of a parallelogram can be called the base. For each base, there's a corresponding altitude that is perpendicular to the base. Okay, so we're starting with parallelograms, but remember, squares, rhombi, and rectangles are all special kinds of parallelograms. So this formula that I'm about to give you also applies to all of those. Okay, so this formula applies to parallelograms and all special kinds of parallelograms such as squares, rectangles, and rhombi. If a parallelogram has an area of capital A square units, a base of B units, and a height of H units, then the area equals base times height. Okay? So again, the base can be any side of the parallelogram. Okay? So you could call this your base if you wanted. But the height has to be perpendicular to the base. Okay? The height must be perpendicular to the base. So example 1, find the perimeter and the area of parallelogram Trvw. Okay? Let's start with the perimeter. You're going to add up all four sides, and remember the opposite sides of a parallelogram are congruent. So I'm going to say perimeter equals 18 plus 12 plus 18 plus 12. Okay. 18 plus 12 plus 18 plus 12 equals 60, and you're going to use the units inches. For the area, it's going to equal base times height. The base is any side, okay? And the height has to be perpendicular to that side. So the area is not 18 times 12 because 12 is not perpendicular to 18, okay? This is the height right here. So I'll draw this off to the side. We have a 30, 60, 90 triangle. That's 90. This is 60, and that's 30. We're trying to find the height. And we know that the hypotenuse is 12. Here's the formulas for 30, 60, 90 triangles. Okay, we're looking for the long leg, so we must get the short leg first. So short leg equals hypotenuse divided by 2. So the short leg is going to equal 12 divided by 2, which of course is 6. Now if you go back to your formulas, you know that the long leg equals the short leg times the square root of 3. So in this case, the long leg is your height, h. So h is going to equal 6 square root of 3, because 6 is the short leg. Okay, so in my area formula, I'm going to do area equals base, which is 18 times 6 square root of 3. You're going to multiply 18 times 6. That's going to be 108 square root of 3. Inches squared. You know what? Just just to make it look nice. I'm not going to write area each time, so just to be consistent, let me get rid of that. Okay. So if I asked you for an exact answer, it would be 108 square root of 3. That would be the area. Okay. If I said give an approximation or round its nearest tenth, you would multiply that by the square root of 3, and you get 187.1. So I'll put both answers. Again, area units squared, so inches squared, inches squared. Okay. So again, if I ask for an exact answer, it would be that, 108 square root of 3. If I said give it as a decimal, round its nearest tenth, it will be 187.1. Okay. So let's try another one like that. Find the perimeter and the area of the parallelogram below. So again, since it's a parallelogram, the opposite sides are going to be congruent. Okay, so the top is 15, so the bottom side will also be 15. The right side is 10, so the left side will also be 10. So for the perimeter, you're going to do 15 plus 10 plus 15 plus 10. Okay. Which will equal 50 inches. Okay, for the area, you're going to do base times height because it's a parallelogram. The base is any side. The height has to be perpendicular to the side, so it's not 15 times 10. Okay, this is going to be the height right there. Let's find that height. The opposite angles are congruent, so since that angle is 45, this angle down here is going to be 45, which means we have a 45, 45, 90 triangle. Okay, so let's do that up over here. Not a perfect drawing by any means. So that's 45, 45. Now we know that this side is 10, so this side right here is also 10. So this is going to be 10. The leg equals the hypotenuse divided by the square root of 2. Okay? So the leg represents the height, h. Both legs are the same, remember. So I'm going to say h equals, actually, no, let me write that out first. I think we're good. We're running out of room anyway. So the height, h, equals the hypotenuse, 10, divided by the square root of 2. You're not going to keep it like that because you cannot have a radical in the denominator. So what I'm going to do is I'm going to multiply by square root of 2 over square root of 2. So my answers are in the proper form. That's going to give me 10 square root of 2 over 2, which equals 5 square root of 2. So that's the height. So in the area formula, area equals base, which is 15, times the height, which is 5 square root of 2. Okay. And again, let's give the answer as a radical, and let's give it as a decimal, because you never know how I'm going to ask it. I don't want to keep writing area over and over. So let's do 15 times 5. That's going to be 75. So 75 square root of 2 is one possible answer. Inches squared. And if I asked you for a decimal, you would multiply 75 by the square root of 2, and you get about 106.1. Inches squared. You never know how I'm going to ask you for your answer. Okay. Example 3. The Wilsons are planning to recarpet part of the first floor of the house. Find the amount of carpeting needed to cover the living room, the den, and the hall. Okay. So you're just going to find the area of each and then add them all together. So the living room is 15 feet by 13 feet. Do that down here. $15 times 13. 195 feet squared. Let's do the den next. The den is 9 times 15. $135 feet squared. Then comes the hall. So the question is, what is this length down here? If you look at the top, the entire length is 35. 30 plus 5 is 35. So the bottom, the length also has to be 35. So 15, 15. This will be 5 feet right here. So hall is going to be 5 times 13. Okay? $65 feet squared. Okay, so the total area will be, you can add those together. 195 plus 135 plus 65. Should be 395. So I'm going to say the Wilsons need enough carpeting to cover 395 square feet. Okay. Put it in a sentence because it's a word problem. That would be good. Okay. Next, we're going to do the area of a triangle. Okay. If you can imagine, a triangle is half of a parallelogram. So if a triangle has a base of b and a height of h, then the area equals 1/2 times base times height. Okay. Again, the height must be perpendicular to the base. Okay. So you have 2 examples on that. Now, example 4, this is a bit of an awkward diagram. It's not a parallelogram. Okay, you can see this side is not parallel to this side. These sides also don't look parallel either. Okay, so it's not a parallelogram. But what you have is you have 2 triangles. Okay, well, 2 big triangles, I should say. You have more than 2 triangles. Okay, you have the big triangle up here, x, y, z, and then you have the big triangle down here, x, w, z. You're going to find the area of each triangle and then add them together. Okay. Okay. So start. You know what I'll do? I'll just draw 2 separate triangles to help you see it better. Why not? X, Y, Z, G. So it says XZ is 39 and YG is 21. So the area of this one is going to equal 1/2 times base times height. The base, XZ, is 39. height, YG, is 21. That equals 409.5. And now let's do the other triangle. Call this H. Area equals 1/2 times base times height. The base of that is going to be XZ, which are again the same as the first one, is 39. The height is HW, which is 20. Multiply those together, and you get 390. Because 1/2 times 20 is 10. 10 times 39 is 390. Now you're just going to add up the two areas that you got to get the area of the entire figure. Okay. So I'll say area of the quadrilateral equals 409.5 plus 390 . 799.5 square units. Okay. Find the area of triangle JKM. Okay, so for this one, you're gonna have to find, you know the height is 4, but you gotta find the base JM. So we'll call this X. I'm gonna call this Y. Let's solve for X and Y, and then we'll know the entire base. How am I gonna solve for X and Y? I'm gonna use the Pythagorean Theorem. Now you should know what X is automatically because of the Pythagorean triples. But just in case you don't know what it is automatically, you have to do X squared plus 4 squared equals 5 squared. X squared plus 16 equals 25. X squared equals 9. X equals 3. Now let's solve for Y with the Pythagorean theorem as well. Y squared plus 4 squared equals 8.5 squared. Y squared plus 16 equals 8.5 squared is 72.25. Subtract 16. Y squared equals 56.25. Take the square root of 56.25 and you get Y equals exactly 7.5. Right, now we can do the area. Area equals 1/2 times base times height. The base is going to be Y plus X, which is 10.5 when you add them together. And the height is going to be 4. Multiply those 3 together and you get the final answer is 21 feet squared. Okay. All right, we're rolling right along. We have 2 more pages now. Now we're going to move on to trapezoids and rhombi. Okay, so here's your formula for the area of a trapezoid. Okay, it's 1/2 times the height times base 1 plus base 2. Base 1 and base 2 are your parallel sides, okay? The parallel sides of a trapezoid are going to be your bases. And the height must be perpendicular to those bases. Okay? So in example 6, find the area of the trapezoid below. You know the bases, okay? The bases are the parallel sides. So the bases are going to be 16 and 26. You have to find the height. So here's how I'm going to do that. Break it apart. Like this. This will be my height. Okay. Okay, so what you have here now is you have two congruent triangles. Okay, so this is going to be 16. Okay, this part in the middle is 16 because it's the same as the top. And from there you can gather that this is going to be 5 and this is going to be 5. Okay. Okay, the entire bottom is 26. This part is 16 because it's the same as the top. And the two remaining sections are each going to be 5 and 5 to add to 26. Okay. So now let's get the height. Let's use the Pythagorean Theorem on the triangle on the left. Unless you have it memorized, you probably should have this one memorized. Well, I'm going to do h squared plus 5 squared equals 13 squared. H squared plus 25 equals 169. H squared equals 144. H equals 12. Pythagorean triple, 5, 12, 13. And now we can go into the area of a trapezoid formula. 1/2 times height times base 1 plus base 2. We just solve for the height. The height is 12. The bases are the parallel sides. So in the original problem, the parallel sides are going to be 16 and 26. So those will be the bases. One half times 12. 16 plus 26 is 42. 42 times 1/2 times 12 will be 252. Meters squared. Okay. One more problem. Okay. We call that a rhombus. It's a special type of parallelogram. Therefore, you can use the formula for the area of parallelogram to also find the area of a rhombus. So if you want to find the area of a rhombus, you could just do base times height. But there's also another formula you could use for a rhombus. Okay, there's another formula. So depending on what information you have, that will determine which formula you want to use. Okay. Here's the other formula. Okay. If a rhombus has diagonals with label D1 and D2, then you can say that the area equals 1/2 times diagonal 1 times diagonal 2. Okay? So 1/2 times the diagonal 1 times the diagonal 2. Find the area of rhombus EFGH. Okay, so again, there's two ways you could do it. You could do base times height if you wanted, or you could do 1/2 times diagonal 1 times diagonal 2. So let's draw in the diagonals and let's use that one. That's one of the diagonals. Make it a little darker. I'm going to draw on the other diagonal. Okay. Let's first look at diagonal EG. Now you could use the distance formula to find that diagonal if you wanted, or you could just count because it's a nice horizontal line. EG is 1, 2, 3, 4, 5, 6. EG is 6. So one of the diagonals is going to be 6. And what's the other diagonal? What's diagonal FH? You could count if you wanted. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that's our formula. Multiply them and you get 24 units squared. All right. So again, that was just the basics. But today we did the area of parallelograms, triangles, trapezoids, and rhombi.